Okay, so my lecture is not going to be that long, so you have more time to work on the quiz. So we are here. On paper, we were supposed to go up to 4.5. I'm already done with 4.5, and I'm halfway through 4.6. Okay, so I think I got up to here. And so we would pick up on the graphs, which I really wasn't going to do a whole lot today. Okay, and some other problems here. So I'll introduce the graphs of the tangent, cotangent, secant, cosecant, and make a comment or two about how you work out some of these problems over here, and then that's about it. Then the rest of the time, I'll let you have for the quiz. Okay. So we've already done the graphs of sine and cosine. Okay, so a reminder of the graphs of the sine and cosine. Both sine and cosine have periods of 2 pi. So one period of the sine starts at the origin, goes to maximum, 0, minimum, 0. Okay, so there's the graph. Again, if you want to put it on your cheat sheet, you may. Cosine, one period can begin at 0, 1. Okay, then it goes to 0, minimum, 0, maximum. So it goes maximum, 0, minimum, 0, maximum. You say maximum and minimum are 1 and negative 1. Yeah, that's right. But remember, if you have a coefficient in front, like 2, then it'll go from 2 to negative 2, right? And so on. All right, so here's the graph of the tangent. Okay, how do I get the graph of the tangent? Again, if you want to put this in your cheat sheet, you may. But so I'll talk a little bit about theory. It's sine x divided by cosine x. Okay, sine divided by cosine. All right, first let's talk about when is this 0. So if I have a fraction and it equals 0, when is a fraction equal to 0? Well, whenever the numerator is 0. Okay, so the exact same locations where the sine of x is 0, the tangent is also 0. That would be at 0, pi, 2 pi, and so on. So notice at 0 and pi, I didn't put 2 pi because I didn't have space, but negative pi. Okay, so the zeros for the tangent are the same as the zeros for the sine, 0, pi, 2 pi, and so on. Okay. Now, it looks like I have some asymptotes. Okay, well, that would be undefined values. Since tangent is defined as a fraction, that means whenever the cosine of x is 0, the tangent is undefined. So if I look at the graph of the cosine, pi over 2, 3 pi over 2, pi over 2, undefined, asymptote, 3 pi over 2, undefined. And if I were to go backwards, likewise, negative pi over 2, negative 3 pi over 2, and so on. Okay, and then other thing about fractions, when is a fraction equal to 1? A fraction is equal to 1 when the top and bottom are equal. Okay, and well, that happens at pi over 4 because both the sine and cosine are radical 2 over 2. So at pi over 4, I should have 1. Okay, so this is the point pi over 4, 1. Okay, this is negative pi over 4, negative 1. Okay, you don't have to memorize this really. I mean, you get the ideas in this picture here. But negative pi over 4, the sine and the cosine are opposite. One is radical 2 over 2. The other is negative radical 2 over 2. So when you take the ratio, it's negative 1. So anyway, the tangent looks something like this. The period is pi. So you get an entire period just within here. It's an increasing function. And then after that, you just copy and paste. There's another branch here, another branch here, and so on. Okay, it's on the recording. You can look at the recording. But here's the tangent function. It's an increasing function. It always goes up, goes through the origin. Okay, something to notice is that you have all these asymptotes, right? So it goes up like that and it goes down like that. Okay, if it's 0. And then right here, okay, so halfway between 0 and the asymptote, you have 1. We'll need that a little bit later. And over here, you have a negative 1. Same thing over here, 0, asymptote. Right here, there's a 1 and there's a negative 1 and so on. All right, that's tangent. Cotangent looks like this. It's a decreasing function. It always goes down. It's cosine over sine. So if I do the same analysis, when is the cotangent equal to 0? Well, that means the cosine is 0. A fraction is 0 when the numerator is 0. So when is the cosine equal to 0? pi over 2, 3 pi over 2, and so on. So there it is, pi over 2, 3 pi over 2. And the cotangent is undefined whenever the denominator is 0. So whenever the sine of x is 0, undefined, I have an asymptote. So when is the sine 0? 0, pi, 2 pi. So undefined at 0, pi, 2 pi, and so on. And just like before, when is a fraction equal to 1? When the top and bottom are the same, that's at pi over 4. So pi over 4, comma 1. This would be 3 pi over 4, negative 1. And likewise over here, if I go halfway between here and here, the y value is 1. And if I go halfway here, it'd be at negative 1, and so on. Okay, so that's the cotangent function. X equals 0, pi, 2 pi. So the period is pi. So for tangent, period is pi. Cotangent, period is also pi. Tangent's an increasing function, always goes up. Cotangent is always decreasing. Okay. If we were meeting face to face, I'd have you memorize this, but since we're not, you don't. I have my corny memory trick. I might as well just share it with you anyway, but you don't really need it. If this one's going up, this one's going down. If you're getting a tan, like a suntan, you're normally looking up. You're looking up at the sun. And a cot, if you're lying down on a cot, you're lying down, right? So anyway, take it or leave it. So when you're getting a tan, you're looking up generally, so the function goes up. If you're lying down on a cot, then you're going down. Okay, so that's that. Okay, and then I talked a little bit before about the inverse of the sine and cosine, secant, cosecant. Okay, so here's the sine, reciprocal is the cosecant. Right, so look at the red graph, which is the sine function, same as this one. Okay, so just some key ideas. The reciprocal of 1 is 1, so they both touch there. The reciprocal of negative 1 is negative 1, so they both touch there. Whenever the sine of x is 0, the cosecant is undefined because you cannot have 1 over 0. So look at where the sine of x is 0. 0, pi, 2 pi. That means asymptote, asymptote, asymptote for the green function. Okay, and a property of the reciprocal is, well, if numbers go up, the reciprocals go down. Okay, so follow the progression that I will give you for reciprocals. Okay, 2 1/2, 3 1/3, 4 1/4, 5 1/5, 6 1/6, 7 1/7, right? So as the numbers 2, 3, 4, 5, 6, 7 get bigger, the reciprocals get smaller, don't they? 1/2, 1/3, 1/4, 1/5. Okay, so that means when one function goes up, the other goes down. So if the sine function goes down like that, the reciprocal cosecant will go up. Over here, the sine goes up, that means the cosecant goes down, and so on. And the same thing happens over here. All right, so in green is the cosecant. Again, you can put this on your cheat sheet if you want, but it does a lot of u upside down u, and it keeps going. The period is 2 pi, just like the reciprocal function, the sine. So it has up, down, you know, down, up. It just keeps doing that same thing. And finally, for the secant function, secant of x, which is the reciprocal of the cosine, same game. Okay. Whenever the cosine is 1, the secant is also 1 because the reciprocal of 1 is 1. Okay, so in red, I've got the cosine function. That's just like this one. The reciprocal of 1 is 1, so they touch there and there. The reciprocal of negative 1 is negative 1, so they agree here. And just like over here, wherever the cosine is 0, the secant is undefined because you can't have 1 over 0. So at pi over 2, 3 pi over 2, the cosine is 0. 1 over 0 is undefined, so asymptote, asymptote. And play the same game. If one function goes up, the other goes down. So in red, the cosine here, it's going down, so here it's going up. Here, cosine is going down, so secant is going up. Red is going up, so this will go down. This one goes down, so this one goes up. Okay, so in green is one period of the secant function. Period is 2 pi. Now, it's kind of deceiving even though I only drew one period like this, it really has the same shape as the cosecant. So if you were to keep going, this still goes U-shape, and that's U-shape, and it's upside U. In other words, it looks exactly the same as cosecant shifted over. So again, it's U-shape, upside down U, U, upside down U, and so on. Okay. All right, so again, here are the graphs. And it's on the recording if you want to look at the recording later. So this is tangent, period is pi, goes through the origin. Okay, key thing to notice is that if I go halfway between 0 and an asymptote, I'm at 1. Halfway between this asymptote and 0, it's -1. Tangent's always increasing. Likewise for cotangent, if I go halfway between 0 and an asymptote, you're either at 1 or -1. So here it's 1, here it's -1. How do you know which it is? Cotangent's always decreasing, so it's always going down. Okay, likewise here, if you look at the 0 and the asymptote, halfway is either going to be 1 or -1. And likewise on this side, halfway is either going to be 1 or -1. So well, how do you know? How do you know it's not here? Well, if it were here, then I'd be going up, but cotangent's always going down. It's a decreasing function. Okay, and period is pi. Cosecant and secant, period is still 2 pi. They both have this U upside down U, U upside down U pattern. Okay, even though I only drew one period like that, it still has the same shape because this next branch would go like that, right? U shape, and this one would be U shape. The next one would be upside down U, and so on. Okay, I'll just talk real briefly about one problem, 17, and then I'll stop, and then I'll give you the quiz. Y equals 3 tangent of x. Okay. Now, before we would say amplitude. In fact, on this quiz, you have to consider amplitude. But we don't say the word amplitude for any of the other functions. So we could have a coefficient in front for a tangent, cotangent, secant, cosecant, but we don't call it amplitude. Okay. So why don't we call it? Well, one of the definitions of amplitude is maximum minus minimum divided by 2. But if you look, these 4 trig functions, they don't have a maximum or minimum, right? Tangent, there's no maximum, there's no minimum. It just goes up, 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 and down, 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 down. Likewise for cotangent, so there is no maximum or minimum. And likewise, if you look at cosecant and secant, there's no maximum or minimum. They go as high as you want, and they go as low as you want. Okay, but we still want to talk a little bit about the graph of that. Okay, so I've got that right over here. So it's hopefully it's a simple concept. Now the asymptotes stay the same. Okay, so in red I have the original tangent. So temporarily ignore the green. Okay, so red is a tangent, goes through the origin. I go halfway between 0 and the asymptote, 1. Halfway between 0 and the asymptote, -1. So how do you know if it's 1 or -1? I remember tangent's always increasing. Tangent's increasing. So if it's increasing here to here, it must be 1. This one must be -1. All right, here's all that happens if I put a 3 in front. Okay. Well, 3 times 0 is 0, so they match here. But I'll just plot what happens to these points. Okay, so this happens to be pi over 4. Okay, right here, that portion, tangent of pi over 4 is 1, so there's 1. And what do you get when you multiply by 3? 1 times 3 is 3, so you're up here. And likewise, if you look at the red graph, tangent of negative pi over 4 is -1. If I multiply that by 3, I'm down at -3. So I'll just connect that point, and that point. So it goes up quicker, steeper here and steeper here. So that's all. So that's all we have to do. Okay. We don't really say we change the amplitude. It still goes from -infinity to infinity for the range. Okay. So one more time, the red is the original tangent. 3 means, okay, well, this was 1, now it's 3. This was -1, now it's -3. And 0, 3 times 0 is 0. So I look only at the green points, I just connect it, it looks like that. So it's sort of the same shape, except that it goes up steeper. Same asymptotes. Okay. Now what's going to change the asymptote is if I have a coefficient in front of the x, like 2x, something like that. Okay, we'll consider that next time. All right, but I'm going to stop right now and give you the quiz. All right, so get your cell phones out and your cameras. And then I'll put you in your breakout rooms and so on. Okay, I'm still recording, so you can check the recording on this also. All right, I'm not sure I can get this all in one. I don't think I can. Might need 2 pictures for this. So I'll split it into 2. Okay, find a sine function for this graph. I'll give you the key ideas. This is pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6. Okay, for the y values, that looks like 1, negative 1, 1. That looks like 1, 2, 3, and back to 1. Okay, so key things you want to ask yourself is amplitude, period, what's the range? Is there any shift? And one thing I'll notice for the sine function, it starts down, so that should be a hint. Okay, what happens to a regular sine function? It starts up, but this one goes down, so that should be a hint. Okay, and the cosine function this time. Oh boy, a lot of negatives they give us. So it goes like that. That does seem to be the general shape of the cosine function. Here are some key points. -1 to 0. And this is -1 comma -2.5. 0 comma -2.5. Halfway it's -0.5, -3.5. Okay, and they've got this. So this looks like it's -3. The y coordinate is -3. 1/4 of the way and 3/4 of the way. -1, -2.5, -0.5, -3.5, 0 comma -2.5. And for hints, find the amplitude, period, range, and shifts. Okay, all right, so that should be enough time, I would hope. So go ahead and get started. I'll put you in your breakout rooms. Do 9:10 on Monday as usual. Okay, so go ahead and get started. I'll set up your breakout rooms. Okay, and as usual, if your breakout room ever gets to have too few students, I might move you. So look to be possibly moved somewhere else. Okay, so you have an invitation. Please join your breakout room now, please. Risa, please join your breakout room.
Professor?
Yes.
Can you show me the question again, please? I went to the bathroom real quick.
Do you have your camera ready?
Oh, yeah.
Okay, it might take me a couple minutes because I already shut it off. And it's
Oh,
going to
okay.
take 2 pictures.
Okay, sure.
It won't fit on just one.
Okay.
Okay, there's question number 1.
Go number 1.
Okay, and number 2, and there's a hint on the bottom also.
Okay.
Okay,
This is it.
yeah, that's it.
Okay, thank you very much.
Okay, thank you.
I was in breakout room 1.
Okay, I'm going to move you to a different room. Okay, go ahead and try to join a room now, please.